Thank you.
You're welcome. Okay. So here's an example. Did you see how complicated that question is? Right? So many n happening, so many radical happening. So I will start to limit the comparison test. That's something really complicated for the like radical or so many n. We will definitely start to limit the comparison test. Okay. So first, this is my original question. Oh, here is my A of n. Okay. Then make sure everything positive, right? If I plug in the 1, if I plug in the 2, everything has to be positive. That's the first condition set. Okay. So A of n is that one. Third root of the n over that one, right? Square root, right? N cube plus 4n plus 3. Okay. Okay. So what is b of n in this case? I need to find the b of n in this case. Anyone?
Cube root of n over square root of n3?
Yeah, it's gonna be the highest power of the numerator and the denominator. So that's it. Okay, so that's my third root of the n and then n cube. So that's the b of it. So I set up the sofa that way. Okay. Then this one also positive, right? If you plug in the 1, 2, 3. Yep. So I'm gonna take the limit. So limit n goes infinity a of n over the b of n. Okay? So a of n over the b of n. So I'm gonna do limit n goes infinity. So here's my a of n. The square root n cube plus 4n plus 3. Then divide by the b of n. Right? Which means I have to take the reciprocal of that one. Okay. So it's b square root of the n cube and then third root of the n. Okay. So that's what I got. The good thing about that limit, you can see at least that one I can cross out each other. Okay. I can cross out each other. This guy I cannot cross out. But actually, it's at least the limit makes a little nicer. Okay. So look at the limit. Yeah. Limit n goes infinity, right? N cubed, right? Square root n cubed plus 4n plus 3. So how do you take that limit?
The coefficients by each other?
Yeah, because same degree is coefficient to each other. What's the coefficient here?
1.
1 over 1. Oh, it's a 1 over 1, right? Which is 1. So that's exactly say, oh, there is some limit exists because it's b1, right? Limit has to be positive. Oh, I got it. Right? Limit has to be positive. So now this part is done. Then now I have to make sure either b of n is convergent or divergent. Okay, so here's my b of n. Okay, so limit, n equal 1 to infinity of the b of n. N equal 1 to infinity of that one. Third root of the n over n cube. Okay. So how are we gonna do that? How are we gonna find that one? Did you see the top and the bottom? Top has n but another exponent, right? The denominator has n, another exponent. Can you simplify? Okay. N equal 1 to infinity. What's my exponent going on here? N. What's this exponent say? Here, 1 over what? 3, right? Everybody okay, right? That's the index 3. Then what's this one say? N.
3 over 2.
3 over 2, right? I need to simplify here. Right? So n equal 1 to infinity. So what's my exponent if you simplify that part? N what? Your exponent has to be what? 1 over 3 subtract 3 over 2. Right? Exponent has to be subtract each other. So what's the 1 over 3 minus 3 over 2? Okay. Summation n equal 1 to infinity n. So just a common denominator, which is 6. So what do you get? Here is 2 over 9. 2 minus 9, which is what? Anyone?
7.
11.
No, 6.
Hold on. 2 minus 9, right? This one. 2 over minus 7, right? Minus 7. And you remember that techniques? This is the most common technique for the p-value. What's my power p in this case? Right? So we can use the p-value test. So what's the power p in this case? 1 over n. Make sure p-value is always 1 over the 1 over p series. Sorry, the p series. It's be always 1 over. You need 1. 1 over what? 7 over 6. What's the p in this case? P is
7 over 6.
7 over 6. But which is bigger than 1.
1.
Right? So what I say? If bigger than 1, answer is convergent. Right? Convergent. So by, okay, you gotta write to, what's the test of P series? It be convergent. So we end up the B of n is convergent. So what's that? If B of n is convergent, so original question say also convergent. Right? So by, which test am I using? Originally, what's my test?
Limit.
Limit the comparison test. Limit the comparison test to say, so summation n equal 1 to infinity, original question that one, right? Third root of the n over square root of n cube plus 4n plus 3 is convergent. Okay? That's the answer. Any questions so far? How you guys think? Are you guys getting better? You guys okay for the limit comparison test? That guy.
Yeah, makes sense.
That makes sense? Okay. Again, as I mentioned, exam 4, if you look at the product, like, Weber sign, I know it's big questions are pretty much convergent or divergent. I mean, you cannot guess because I'm going to check your work and make sure which test you are using. So I will check your work. If you don't write your test, I will definitely mark it off even you get the right answer on the Weber sign. Make sure you got to show me the work. Though. Alright, so that's the limit comparison test. Alright, can I go to new test today? Because we have 3 more tests to cover today. 3 more tests. Okay.
Yes.
Alright, so we are moving on new guy. It's be 11.5 today. 11.5. Yeah. So 11.5, it's be another test. It's an alternate series. It's be the alternate series test. Yeah. So what's the alternate series? It's pretty much, look at this one. There are 2 examples. Alternate series is, there is a one that you are subtracting 1 over 2. You are adding 1 over 3. You are subtracting 1 over 4. You can say it's a plus number, negative number, positive number, negative number. So that's called alternate. So you are adding positive, negative, positive, negative. Well, negative, positive, negative, positive. So it's always alternately, the number is positive and negative. So that's called the alternate series test. So whenever you see negative 1 to the power, right? Negative 1 to the power, that's pretty much we use alternate series test. Okay? It's not too hard. Okay? So here's the form. Okay, you guys see, it's always negative 1 to the some power. Right? Otherwise, it's not alternate. Okay? Negative 1 to the some power. Negative 1 to the some power. That's the B part. Okay? So it doesn't include the negative 1 to the power. It's just exclude the negative 1 to the power. Then whatever the extra stuff, that's the B. Okay? So first, there is some condition has to be satisfied to use alternate series test. Alternating series test. Okay? Did you understand what this means? Okay. B of n plus 1 is less than or equal to B of n. The all n. N means 1, 2, 3, 4, 5 until infinity. So what this means? This means, okay, if I plug in the 1, right? B of 1. Then if I plug in the 1, have to be less than B of 2, right? Then if I plug in the 1 here, if I plug in the 1 here. Then if I plug in the 2 here, if I plug in the 2 here, what's happening? Okay? B of 2 have to be less than equal to B of 3. Right? If I plug in 3 here, if I plug in 3 here, what's happening? Right? B of 3 have to be less than equal to B of 4. And so on. What this means? B of 1 is less than equal to B of 2. Right? B of 2 is less than equal to B of 3. The B of 3 is less than equal to B of 4. What's happening to my B? B of 1 is biggest. Next one, B of 2. Next one, B of 3. Next one, B of 4. What's happening to my numbers? B of n is, well, getting smaller and smaller and smaller. Oh, it is decreasing, no? Oh, number is getting smaller. It's a big decreasing. So that's the first condition you have to say. Satisfied, B of n is decreasing. That means me. The one more, limit have to be 0. If B of n is limit is 0, then if you satisfy that two conditions, they say, oh, it is convergent. That's this means. Okay. So make sure check the two things. They satisfy that two conditions, you can say, oh, it is convergent. Just look at the example. Let's do the example together. Okay. So here is summations n equal 1 to infinity, right? Negative 1 over n minus 1 power over the n. Did you see? Oh, it's negative 1 to the power n, which means, oh, it's be alternate happening. It's negative, positive happening. Which means n equal 1 to infinity, negative 1 to the n minus 1 times 1 over n, right? This is exactly I can write it that way. So I want you to make sure. So this part is right here. That's my B happening. Okay. Oh, this guy. It's me, my B of n. Okay. So let's check the two things. So is the B of n, it is 1 over n. Can I say decreasing? If n equal 1, n equal 2, n equal 3, n equal 4, what do you say? Right? 1 over 1, 1 over 2, 1 over 3, 1 over 4. Is this decreasing or not? What do you think? It is? Yeah, it's decreasing, right?
Yes.
Decreasing. It's clearly decreasing from the 1 to infinity, right? from 1 to infinity. Oh, it is decreasing. Okay, so first things, it's checked. Second, I gotta check the limit, right? So what's my limit to say? N goes infinity b of n. Limit n goes infinity 1 over n. If n goes bigger and bigger and bigger, what's happening? 1 over infinity, which is what? It is, probably everybody know it. I'm sure it's b 0. Right? Oh, two things is checked. Then what's the final answer? Say, oh, it's b convergent. So here is answer by alternate series test set. Series test the questions n equal 1 to infinity, negative 1 to n minus 1 over the n is convergent. It's easy, right? It's not too hard. You just make sure you know what you have to do to check two things. Any questions? I mean, you can say, or you can chat it, or you can just show me, like, thumbs up, symbol reactions. So I know what you're doing.
Professor?
Yeah, what's that?
So by taking the limit is we just make it sure that it's gonna be on limit, then plug it in the bound.
Yeah, plug in the because all of it n have to be infinity, no? Yeah.
Okay.
N have to be infinity. The limit is because it's go to the infinity. Okay. Yes. N go into the infinity. That's not gonna change it. Yeah. Yeah. Alright. Okay, let's try that one. Let's try another one. Okay. Because alternate series test is not the hard one. It's pretty straightforward. Okay. So let's get to this guy. Yeah? Alright. Yeah, can you see n equal 1 to infinity? Right. Negative 1 to the power n. Right? 3n over the 4n minus 1. Okay. Okay, I'm sure this is alternate happening. Negative 1, positive 1, negative 1, positive 1 happening. Okay, so which means this guy, it be my b of n, right? B of n. Okay. First things, let me make sure you check it. I really want to make sure, is this decreasing or not? How
It'll
can I
be
know?
decreasing? Oh, sorry.
No, it's alright. Can you say it is decreasing? Decreasing n equal 1, n equal 2, n equal 3. Is this decreasing? Right? If I put the 1, if I put the 2, if I put the 3, if I put the 4, is this really decreasing or not?
Yeah, it does, because the values, they get smaller.
Yeah, so make sure it's decreasing. Right? 1 to infinity. So let's make sure number 2. Let's take the limit, right? Let's take the limit. So limit n goes infinity of the b of n. Limit n goes infinity. What's the 3n over the 4n minus 1 if you take the limit? What do you see here? Right? Did you see that? It's the same degree what I said, if I have the same degree.
If you divide by the greatest exponent,
yeah,
you would,
but it's the same degree. What's my limit? Constant.
Yeah, coefficient, yeah.
Which is what?
Yeah, 3 over 4.
3 over 4. Oh, it's a 3 over 4. What I said? Oh, I should get the 0. Otherwise, that test doesn't work. Oh, I failed it. Oh, I'm failing alternate series test. Does that make sense? Oh. Alternate series test doesn't work. Which means I should not use that test. Then now, what's my choice here? I cannot use alternate series. Okay, then we didn't do so. So, which test should I use right now? Okay.
Divergent.
Yes, make sure. Those are, everything has to be positive, right? Okay, those are, everything has to be positive. I have a negative happening. Clearly, I cannot use that one. I don't think I like to take this integral test. Okay, integral test has to be also positive. If I have a negative, integral test never happen. Then clearly that's not the P series happening. I don't see what's the power of P happening. Then that's not the geometric series. Oh, I should use divergent test. What's the divergent test say? Okay, divergent test say, let's take the limit. Limit means whole thing of the limit. This limit. I'm gonna take the limit of the whole thing. Okay, so limit of n equal n goes infinity of the a of n. Okay, so limit, not the summations. Okay. Limit n goes infinity of the whole things. Whole things I'm gonna take it. Okay. Negative 1 to the power n, 3n, 3n over 4n minus 1. Okay. Yeah, what's this limit? What's this guy? Forget this part, right? At least we know, oh, it's a 3 over 4. Just like that one. Right? It's the same degree, 3 over 4. Right? So what's this happening? If I plug in the 1, if I plug in the 2, if I plug in the 3, if I plug in the 4, if n goes bigger and bigger and bigger, what's really happening?
Plus or minus?
Yeah, plus or minus, right? Because it's just a negative 1 power. Oh, it's a plus or minus. It can be either. Okay? Plus or minus. Then what to say? It's not equal 0. Yeah, clearly not equal 0. We don't know plus or minus which one. But at least I know that's not the equal 0. So what's the divergent test say? If it is not equal 0, answer is it's divergent. Oh, so here's I know. It's by divergent test. This guy, it's a divergent. 3n over 4n minus 1 is divergent. Let's see, any questions here? Okay, let me see. Why it's b plus or minus 1? Okay. Think about it. Forget this part. Forget just that part. Just that part. If I plug in the 1, what you get? Negative 1, right? If I plug in the 2, positive 1, right? Did you understand that? If I plug in the 1 here, that's a positive 1, right? A negative 1, right? If I plug in the 2, it's a positive 1, right? If I plug in the 3, negative 1. So you don't have a choice. This can be only positive or negative. So that's why the plus minus happening, positive 1 or negative 1. Because that part is 3 over 4. Okay, you got it? But just I know it's not 0. That's why it's divergent test. So here's the technique you should remember. If alternate series test doesn't work, if that guy doesn't work, I'm sure answer is divergent test. You have to use divergent test. Well, that's the one technique you should remember. If alternate series test doesn't work, let's go to divergent. That's pretty much we use all the time. You guys good?
Professor?
Yeah.
Is it possible to do all of it divergent test first, then if divergent test fails, you can do the other test?
I mean, you can do it, but sometimes taking a limit, it's not too easy. It's not too easy, yeah. The most of the test can be zero happening. Most of the limit is it's gonna be zero. Most of the time you're gonna see it's zero happening. Yeah, I mean you can try the divergent test, and if it doesn't work, you can try something else. You can do it. I will pretty much check first. Yes, I do check the divergent test. Then maybe depend on your functions. If integral looks easy, I will take the integral test as well. I do that. Because this geometric and P series is a more specific form you need. You need what's the R. The P series has to be exactly what's the 1 over power P. That this form is a really specialized. If you don't see the nice like right form, you never use that guy. Right? The limit comparison test, it's gotta be another nice, it's really complicated A of n, that's a limit comparison test we're gonna start using it. Yes. Yeah, let's try that one, another one. Let's try that one. Okay. So you guys try. Oh, here we go, that one. Okay. Let's see that one. Well, did you see it's a negative, positive, negative, positive, negative happening? That's definitely it's alternate happening. No? Yeah, can you change the form, right? N equal 1 to infinity negative 1. First number is negative. I'm sure it's negative power n, because if I plug in the 1, I have to have a negative sign happening. Okay? Then how do you make the 2 over 5, 5 over 6, 6 over 7, 8 over 8, 10 over 9? Can you see that part? How do you do the 2 over 5? How do you do the 4 over 6? How do you do the 6 over 7? How do you do the 8 over 8? Okay, forget the denominator. Pay attention to the numerator. Numerator says 2, 4, 6, 8, or 10. So what's the numerator is happening here? Because first number has to be 2 though. Second number has to be 4. Third number has to be
2n?
2n, that's it. Did you see that 2n? Because if I plug in the 1, it's gotta be the 2, right? If I plug in the 2, it's gotta be 4. Right? If I plug in the 3, it's gotta be the 6. Okay, it's 2n. Yeah, how about the denominator? It's gotta be 5, 6, 7, 8, or 9. Okay, n plus 1. If I plug in the 1, it's gotta be the 5 though. N plus 1. 4, that's it. Everybody okay the 4? Because if I put the 1, it's gotta be 5, right? If I put the 2, it's gotta be the 6. So it's n plus 4. Alright. So let me make sure. So it's definitely the alternate series happening because negative 1. So b of n is 2n over the n plus 4. So I wanna make sure. Is this meaning decreasing? Okay, that's the alternate series. It is decreasing. Is this decreasing or not? I really want to make sure that one. If that number is decreasing or not. If I plug in the 1, if I plug in the 2, if I plug in the 3, so what do you see?
It actually increases.
Increasing, right? That if you look at it, 2 over 5, next one 5 over 6, 6 over 7, 8 over 8. It's definitely getting bigger and bigger. It's a 1, next one 10 over 9. Oh, it is increasing, right? Oh, I already failed. I already failed the alternate series test because it's gotta be decreasing. Oh. alternate series test doesn't work. But what I say? If alternate series test doesn't work, which test we use?
Divergent.
Divergent. Oh, I gotta go straight to the divergent test. Oh, let's take the limit. Okay, I'm gonna take that limit. Okay, so limit n goes infinity of the a of n. Limit n goes infinity of the whole things. Right? Negative 1 to the power n. 2n over the n plus 4. Right. Now let's think about what's the limit in this case.
2?
Yeah, this part 2 over 1, right? Because same degree. Oh, it's a 2. Right? But what's happening at that part? If I plug in the 1, if I plug in the 2, if I plug in the 3, if I plug in the 4, what's really happening?
Plus or minus 2?
Yes, plus minus. Everybody okay that? Again, it's power 1, power 2, power 3 though. It's positive or negative, positive, negative. Oh, it's a plus minus 2. But at least I know it's not equal 0. Okay? Oh, that's not equal 0. Okay. Just that finally, okay, by no alternative, divergent test. Okay. By divergent test. Stay this guy. Summation n equal 1 to infinity, negative 1 to power n, 2n over n plus 4 is divergent. Yes. Any questions here? Hopefully you guys okay here. Yes. The last one for this section. Well, everything same. It's alternate series. It's pretty simple. Okay, everything same. Only last question, that one I wanna do. Because some of the trick function I wanna make sure you understand it. Next page. Yeah. This one clearly, oh, it's be alternate series, right? So here's my b of n. The sign pi over n happening, right? Okay? So this is my b of n. I want to make sure that what's the first condition you have to check? Number 1, what do you have to check?
Decreasing?
Decreasing. Is this decreasing or not? I really want to make sure. Is this decreasing or not? Sine pi over n is, are you sure it is decreasing? If I plug in the 1, if I plug in the 2, if I plug in the 3, if I plug in the 4, is this decreasing or not? Okay.
Yes.
Yes, how do you know?
It's reaching 0?
Okay, yes, that's it, that's it. Right. Let me make sure you guys understand the trick function. Right. Right. If I have sine, if I plug in the 1, right, it's a pi. If I plug in the 2, pi over 2. If I plug in the 3, pi over 3, right? If I plug in the 4, pi over 4, right? If I plug in pi over 5, right? Sine pi over 6. What's this guy? Sine pi? It's exceptions. Because everybody knows unit circle, where's the sine pi say? Right? Where's my sine pi say? Here's my pi. What's my sine pi here? Sine pi is 0. What's the sine pi over 2 here? Okay. Sine pi over 2. That's the 1, right? I know it's not decreasing. Actually, from 0 to 1. Wow, that's increasing. But here, what's the pi over 3? Pi over 3 is here, right? About 60 degree. Pi over 3. Right? Pi over 4, it's here, right? Pi over 4. Pi over 5, actually maybe around here, the pi over 5. Okay? Here's pi over 3, pi over 4, pi over 5, pi over 6 here, right? You can see it's a sign value, which is actually y value is getting smaller and smaller and smaller. If angle is getting smaller and smaller and smaller. Except that first number, but after that, I know it's gonna be 1. Here it's radical 3 over 2. Here is radical 2 over 2. I know pi over 5, I cannot calculate it. You need to calculate that. Pi over 6, at least everybody knows it's 1/2. I know number, degree is getting 0. So, yeah, it's a decreasing. Y value is getting smaller and smaller and smaller. Oh, it's a sign is decreasing. So you can say it is decreasing. Okay. So I know number is getting smaller and smaller and smaller decrease. Okay. Because angle is getting approaching 0, meaning y value is getting 0, right? My y value is getting 0. Right? So that is decreased. You got? Yeah, what's the second condition say? What do you need? Limit. N goes infinity of the b of n, which means that guy. Limit. N goes infinity of sine. What's the pi over n? Which means if n is huge, sine pi over huge number, what I mean?
Zero.
Sine 0, right? What's the sine 0 say? Sine 0 is
0.
0, right? Oh, what's the alternate series say? Oh, it's 0.
Oh, I actually good at 0.
Yeah, actually it's going 0. Oh, it's B, or by the alternative series test, say it's convergent. Okay? Oh, so it's by alternate series test summation n equal 1 to infinity negative 1 to the power n sine pi over n is convergent. Okay. So that's the answer. Yes, any questions here? You good? Hopefully you understand that here. Okay. Yes, this is end of this alternative series test. Do you have any questions right now? Okay. Alternative series is not too bad, right? I hope you guys understand okay here. Okay. Alright, we're gonna move on to one more test today. 11.6. Okay, 11.6. This guy. 11.6 is, okay, listen carefully because some students start to get confused here. It's absolute value convergent. And then ratio test, root test it's different to test again. So there's a convergent or divergent, right? Okay. There is convergent or divergent. There are two types of the convergent. One is called this guy, absolute convergent. The other one called conditionally convergent. That one. Conditionally convergent. convergent. The divergent is divergent, nothing. So convergent has a two different type of the convergent. So one is called the absolute convergent. Okay, here is absolute convergent. That means. Then another one called conditionally convergent. Conditionally convergent. So it's two different types of the convergent happening. Okay. Then what is absolutely convergent? What's the conditionally convergent? Okay. So what's the absolutely convergent means? If you have A of n, let's take the absolute value. Then if the absolute value is convergent, then we call absolutely convergent. Then what's the conditionally convergent? Is if you take the absolute value, it is divergent. But if you don't take it, it's a convergent. Okay. If you take the absolute value, it is divergent. But if you don't take it, it's a convergent. Then we say conditionally convergent. So look at the example. Look at this one. Negative 1 n minus 1 over the n square. I know this is alternate series happening, right? Negative, positive, negative, positive. So let's take the absolute value here. Right? If I take the absolute value, n square is always positive, nothing change. But negative 1, I know plus or minus happening. But if you take the absolute value, it's everything positive. Right? That's why it's only 1. Okay. Let me stop me if you get confused. Okay? This is a negative 1, positive 1, negative 1, positive 1 happening. But let's take the absolute value. That's why it's just 1. The n square is always positive. That's why it's n square. So we end up with that one. 1 over n square. So which test should I use? That's the P series, right? Because P is 2. Right? If P is bigger than 1, I know it will be the convergent happening. Oh, this is convergent because of the P series. So if I take the absolute value, then we get the convergent. Right? It's convergent. We call it absolutely convergent. So this one, oh, it is absolutely convergent. Absolutely convergent. Now look at this example. Okay, I'm gonna take the absolute value here. Okay, so this part again, it's a positive or negative, positive, negative happening. But take the absolute value, become the 1. The n part, n equal 1, n equal 2, n equal 3. It's everything positive. That's just n. But do you remember this is, it's a power 1, right? P equal 1. It's a, what's a P series say? It's a P equal 1. P series say if P equal 1, it's a divergent. Oh, we end up that this guy, it's a divergent. You see, if absolute value is divergent. Oh, we end up the divergent. Then what's the original test say? This guy. This guy. Okay. The originally, okay, this question we did somewhere. Where is it? Did you remember that this one, alternate series 1? Go back to here. This is exactly same question for that one. No? Original question, this guy. Go back to here. We end up the convergent. But original question said it is convergent. Did you see that? This original question said it is convergent. But if I take the absolute value, it is divergent. So we call conditionally convergent. That's it. You guys okay here? That's it. This is a little tricky. Because convergent has, this guy, two different convergent. It's this absolutely convergent or conditionally convergent. Two different convergent is happening. Yeah. はい。で、here, if you have absolute value convergent, if you end up the absolutely convergent means no matter what, it's always convergent. So you don't need to do anything extra. If it is absolutely convergent means it is convergent. So look at this. Okay, did you understand okay here so far? Yeah. Look at this guy. Look at this guy. Yeah. Look at this guy. Did you see? A of n is positive, right? That means I don't care if I take the absolute value or not, because it's everything's positive. This one too, right? It's everything positive. So this means if you end up the convergent, this is exactly, they say, absolutely convergent. Does that make sense? Because it's already positive number here. That makes, I don't care take the absolute value or not. This is exactly same as absolutely convergent. This one too. Absolutely convergent. There also this guy too. Did you see? Its conditions are positive. So I'm not talking about the negative, right? If this A of n is have to be positive, this is also, again, absolutely convergent too. Also this guy too though. If n equal 1, n equal 2, n equal 3. Oh, it's everything positive. That means absolutely convergent happening too. So they are all talking about the absolutely convergent, to be honest. So there is no conditionally convergent happening here. Everything absolutely convergent, absolutely convergent. Here's absolutely convergent. Here's absolutely convergent. You guys good? This guy we don't know. We don't know because this is a divergent test. Okay. So at least that you should make sure you understand it. This is all absolutely convergent test actually. Alright, so let's practice that guy. Okay, let's practice that guy. Yeah. So look at this guy. Yeah. First, determine that this one is convergent or divergent. Oh. Okay, let's practice that one first. Okay. This is probably easier. Determine the series. This guy is big convergent or conditionally convergent. Convergent means absolutely same, absolutely convergent or conditionally convergent. Two different convergent is happening. Right? So how do you know it? Which convergent am I talking about? Okay. First, I should take the absolute value. Right? If absolute value is convergent, we are done. Right? It's absolutely convergent. If absolute value is divergent, we are having a problem. Okay. So now, first things here. Yeah. Okay. Listen carefully because yes, go ahead.
So, Professor, for this section, everything here is convergent?
No. Some question is divergent happening. No? Some questions. This question is it's talking about which convergent happening. Is absolutely convergent or conditionally convergent. But some questions is not. Some questions say convergent or divergent. Okay? Some question we don't. This one is exactly talking about which type of the convergent. Alright. So first things, what you have to do is always check the absolute value. If the absolute value is convergent, we are done. Absolute value is divergent, we have a problem happening. Okay, so make sure summations. So just listen carefully. This one start everybody get confused. N equal 1 to infinity. Right? I'm gonna take the absolute value. Negative 1 to the power n over 5n plus 1. Yeah, here you go. Okay, so I'm gonna take the absolute value. Then what's happening if I take the absolute value? Negative 1, I put the absolute value, which means everybody okay, 1, right? 1. Okay. Then 5n plus 1, right? You plug in the 1, plug in the 2, plug in the 3, so you know it's everything positive number happening. Oh, 5n plus 1. So far everybody makes sense, right? I took the absolute value, we end up that one. Alright, so now I need to know this one is convergent or divergent. So which test should I use? Okay, you have a choice. Which test should I use? Based on that one. Should I use divergent test? Should I use geometric series? Should I use P series? Should I use integral test? Or comparison test? Clearly not the, it's not the alternate series. There is no negative one happening. Okay, nothing happening here. Okay, go ahead. Sorry, what you say?
I think can't you use the integral test?
You can do integral. Yes. If it looks like easy integral, you should use the integral test. Can I say integral test? Maybe you should try, right? Oh, so f of x is, make sure if you wanna say integral test, there's a 3 conditions you have to mention. It's continuous, positive, and decreasing. Okay. So it's 1 over 5x plus 1. Is this, can I say positive number or continuous?
Yeah, it's continuous.
Yeah, it's continuous, bigger than 1. I can plug in any number bigger than 1. Yes. Can I say positive? Right? It's if I plug in the 1, 2, 3, 4, 5. Oh, it's gonna be the positive number, right? It's a positive. Then, is this, one more thing you gotta say, decreasing? What do you think? If I plug in the 1, 2, 3, 4, 5, is this decreasing? Yeah, it looks like decreasing. Right, on 1 to infinity. Just make sure always you gotta mention 3 conditions. Okay, so looks like integral test looks working for me. So integral, make sure 1 to infinity happening. 1 to infinity, 1 over 5x plus 1 dx. Right? Then again, I cannot take the infinity as a limit. T goes infinity, 1 to t, 1 over 5x plus 1 dx. Alright, I guys remember that limit, that integral. How do you take that integral? That one is not too hard. Sorry. Like your voice is cutting off, so what's that? Which integral that one? Which one is that? Anyone? I'm sure you guys know it.
ln of 5x plus 1.
That's it. So it's b. Limit it's nothing to do with right now, right? Just leave it. Natural log, right? Natural log 5x plus 1. But again, what's happening in my chain rule here?
Times 1/5.
Oh yeah.
Yeah, 1 over 5, right? Right? Because you have to take the inverse. Okay, 1 to t, 1 to t. Alright, so it's almost there. Okay, so I'm gonna plug in 1 over 5. 1 over 5. Plug in the t, right? 5t plus 1. Subtract, I'm plugging the 1. Natural log 6. Okay. Right, I plug in the t. So as t goes infinity, what's really happening? Well, as t goes bigger and bigger and bigger, what's happening to my limit? What's my happening on natural log here?
Minute
Yeah, infinity, right? It's getting just bigger and bigger and bigger, right? So infinity minus natural log 6, which is what's a huge number minus natural log 6, which is what?
Infinite.
Yeah,
So it's
infinity,
equal to
right?
infinity.
It's just a huge number minus such a small number. It's not going to change it. Oh, it's an infinity. So what's that? What's the integral test say? If integral is this guy, divergent, right? This is the divergent. So by integral test, say what? This guy, it is divergent. So this guy is divergent. No? If I take the absolute value, become the divergent. Right? Summation n equal 1 to infinity absolute value negative 1 to power n 5n plus 1 is divergent. Does that make sense here so far? Oh, so now did you understand that? If I take the absolute value, we end up the divergent. Okay, don't answer the conditionally convergent. We don't know. Okay, we don't know. So now, yeah, let's check. If I don't take the absolute value, make sure we have to get the convergent. Right? If I don't take the absolute value, so back to here. Okay, summation n equal 1 to infinity negative 1 to the power n 5n or 5n plus 1. Yeah. So which test should I use? Now I'm not going to take the absolute value. Right? So we have to back to the original questions. So which test should I use now? Based on that list.
Alternating.
That's right. Now I have to take the alternate series. We don't have a choice because it's gonna be the negative one happening. Oh, I should take the alternate series, right? Okay, so which is, what's the b of n in this case? 1 over 5n plus 1, right? Okay, what's the two conditions you have to check? Is this what? What's the two things you have to check? What I say?
Decreasing.
Decreasing. Is this decreasing? If I plug in the n equal 1, n equal 2, n equal 3. Yeah, it is decreasing, right? Because denominator getting bigger and bigger. Yeah, decreasing.
Even previously we said it was decreasing though,
Yeah,
right?
that's right. Yeah, it's decreasing, no? Decreasing. Decreasing, right? 1 to infinity. Alright. Then one more thing what do you have to check? Make sure check the limit. Oh, I need to check the limit. What's my limit to say? Limit n goes infinity b over n. Limit n goes infinity. What's that? 1 over 5n plus 1 set. Sorry. What's that?
Zero.
Hey, this one 0, right? Because n goes infinity. Oh, that's 0. Oh, so we end up the 0. Then we have a decreasing. So what's the question answer say? Oh, it's a convergent. Okay, by yeah. Alternate series test. Right? So it's summation n equal 1 to infinity negative 1 to the power n 5n plus 1 is convergent. Then what's the final answer in this case? If I take the absolute value, it's a divergent. But if I don't take the absolute value, it's a convergent. So which way is that? Right? Is it absolutely convergent or conditionally convergent? Which one is the answer? Conditionally convergent, yes. So n equal 1 to infinity negative 1 to the power n 5n plus 1 is we call CC, conditionally convergent.
So, Professor,
Yeah, what's up?
so what makes it conditionally convergent, you said? If one, we got a divergent, and for the other, we got a convergent?
Sorry, say again one more time? Sorry.
So, no, it's right. So what makes it conditionally convergent is if for one, how do you say, one side we get a divergent and the other one we get a convergent?
Yeah. If I take the absolute value, it's gonna be divergent. If I don't take the absolute value, it's gonna be convergent. Then you have to say conditionally convergent, CC.
Okay, if they were by any chance both convergent, it would make it absolutely then.
Yeah. If you take the absolute value and you end up the convergent here, well, you are done. You don't need to do any extra work. Oh, it's a convergent. It's convergent.
Oh, okay.
Okay. So I don't need to do anything here.
Yeah.
If you end up with this one convergent, you stop it. Okay, I don't need to do anything here. It's convergent. Convergent to convergent.
Oh, okay.
Yeah.
Okay. Thank you.
You're welcome. Okay. I want to make sure one more thing. Let's do this one. So this guy, I know, doesn't say convergent or conditionally convergent or absolutely convergent. This question says exactly a convergent or divergent questions. Yeah. But at least what I know, think about this one. If I plug in the 1, if I plug in the 2, if I plug in the 3, denominator, I know it's everything positive. But numerator, it's a cosine, right? Cosine can be negative number, right? Because cosine is between negative 1 to 1. So can be negative happening here. We just don't know, right? Because cosine is always between, you need to circle, between negative 1 to 1. So sometimes negative might happen here. We just don't know. Right? It doesn't say conditionally convergent or absolutely convergent. Because the question says convergent or divergent. But first things, I'm gonna do, then what's happening if I take the absolute value? Okay? N equal 1 to infinity, I'm gonna take the absolute value. Cosine n over the n squared. Let's take the absolute value. Okay? The summation n equal 1 to infinity. Problem I have is this guy. Because cosine 1, cosine 2, cosine 3, cosine 4, we don't know can be positive or negative happening. Okay? So that's why I have to keep the absolute value. Because we don't know positive or negative, which one happening. But n squared is fine. It's always positive number. Yes, now, which test should I use it? This guy is tricky. This one definitely tricky. Which test should I use it?
Integral?
Ooh, how do you take this integral? Not too easy. I definitely don't want to take the integral of this guy. Because especially I have absolute value. I definitely not going to take the integral test here. And I cannot take the P series because it's not the one here. This one definitely not the geometric series. It's not the geometric. Again, divergent test doesn't work because if n goes bigger and bigger and bigger, well, that's become the zero happening. Right?
Oh, yeah.
Right? I'm looking for no equal 0. So that's not gonna happen. So I'm failing a bunch of the stuff here. Okay. That's definitely not the alternate series because I don't see negative 1 happening here. I don't see it. Okay.
We have a
yeah.
an exponent in the denominator. Can we use the P series?
No. If you have a 1, you have to have a 1. Then I can say P series. Yes. But this one, it's not 1 because can be negative number happening, right? Cosine.
Oh, I see. Yeah.
Cosine can be some number though. It's not the always 1. That's why P series doesn't work.
We have to do direct comparison?
Yeah, I don't have a choice. It's a comparison, especially not the limit comparison. Limit comparison have to be, it's hard to see that way. Okay. Direct comparison test happening. That one is a little hard to do, I guess. So look at this side. Absolute value cosine n over n square. Okay. I'm looking for something bigger. Okay. So I'm gonna find something bigger than my original this guy. I'm finding something is big part. Something bigger than the A. So what's that? How do you find the bigger number? Okay. I'm not gonna change the n square. N square is n square. So if you wanna find something bigger, so numerator has to be maximum
Plus
cosine.
one.
Can you see one? Can you see that way? Did you understand that this way? Why it's 1? Because cosine is always what? Between, no matter what, negative 1 to 1, right? Because you don't have a bigger than 1. So I'm going to take the biggest number of the cosine, which is 1. The numerator doesn't change. Denominator doesn't change. I don't want to change the denominator. Keep the denominator n square. Then I'm going to take the maximum number of the numerator, which is 1. Did you see? It's a bigger. It's a little bigger than that, or can be equal to that. So that's my b of n happening, no? That's this part happening. Oh, that's my b part happening. This guy. But this one makes a little easy for us. Okay. Then now, this is my b, that's my b of n. Then now, can I say convergent? Can I say, so what's the test should I use this guy? Okay. N equal 1 to infinity 1 over n square. Which test should I use this one? Which test should I use it? This one is an easy test.
P series?
P series.
Oh yeah, now you can do
yeah,
P
it's
series.
a P, right? Oh, P is exactly 2. I can see it. Oh, it's a P equal exactly 2. 2. So by P series say, what's that? If bigger than 1, what's the P series say?
Divergent?
Oh, no. If bigger than 1, what do I say?
Convergent?
Convergent.
Oh, my bad.
Yeah, it's alright. Convergent. Oh, this is convergent. Did you remember? We end up that this is convergent, right? B of n, this part is convergent. Did you see that? We end up that this part is convergent, means A of n also have to be what I say. Ah, it's convergent. But this convergent means absolutely convergent. Okay? Oh, this guy, right? This guy, it's convergent. Okay, so by which test are you using? Direct comparison test. Direct comparison test say, right? If I take the absolute value, right, n equal 1 to infinity cosine n over the n square is convergent, right? Remember that if I take the absolute value is convergent, means, oh, it's just a convergent. If I take the absolute value, right? If I take the absolute value, then that is convergent, we say absolutely convergent. Oh, this is also absolutely convergent. But absolutely convergent means, oh, it is convergent. There is no way conditionally convergent happening. Oh, it is convergent. So answer is, this is convergent. Okay, so answer is summation n equal 1 to infinity cosine n over the n square is convergent. So that's the answer. Once you get the absolutely convergent, you just stop it. You don't need to do any extra work. It means it's straight convergent. That's I say. Absolutely convergent means just convergent. Never be divergent. Never be conditionally convergent. It's just done.
So, Professor,
Yes.
so if the answer of the absolute is divergent, then we have to do the
Yeah, we have to do the
non-absolute
yeah.
value.
Yes. We have to do conditionally convergent. Yes. We have to check the another one. Yes. So do we have to write the absolutely? Do we have to write absolutely? No, question doesn't say absolutely. You don't need to write it. It just say convergent. That's fine. But absolute value convergent meaning it's convergent. It's convergent. Yeah. Okay. Any questions here? So far so good. Alright. There's one more test we're gonna do today. Then I think I'm gonna call. Okay. So here it's another test. Okay. Here's another test. It's a ratio test. We're gonna do ratio test. This guy. Ratio test not too bad. Root test is much easy. Okay. Ratio test, root test, it's not too bad at all. Okay. Did you see? So what's the ratio test? Ratio test is I'm gonna straight take the absolute value. So it's a of n plus 1 over the a of n. Then let's take the limit. The limit to say it's less than 1. My answer is absolutely convergent. Which means more convergent. Well, you are done. Okay, you don't need to do anything. But if bigger than 1, that means answer is divergent. Then if it is equal to 1, ratio test doesn't work. It's a fail. So we have to do something else. Okay, we have to do something else. Okay, so let's practice this guy. I know if you see negative 1 to the power n, I know you guys start saying, oh, it's alternate series. Okay. I mean, you can do, but that alternate series, it's not easy to do it. Because I cannot take the limit to this part. This one is really hard to make the limit. Okay. So, we're going to start the ratio test. Okay. So, make sure this guy, this whole thing, it's be our a of n. So let me write for you. Negative 1 to the power n, n cube over 3n. That's the whole thing is a of n. Okay? So what is a of n plus 1 in this case? That means everything n plus 1, n plus 1, n plus 1. Everything I have to change the n plus 1. Okay, so let me do that step by step. This is the first time. So n become the n plus 1. Okay, that's n become n plus 1 to the power cube. Sorry, it's a little hard to see. But over, again, 3 n plus 1. So that's happening. So make sure all n become the n plus 1. I should replace with n plus 1. Okay, this n plus 1. This n plus 1. Okay, so what do you do? I have to take the absolute value of n plus 1 over the n, a of n. So this over this, I have to do it. Okay? So absolute value, a of n plus 1 over the a of n. That's what I'm going to do. Okay? So this is the first time I'm going to do step by step. Okay? So this guy, nothing changes. Absolute value, negative 1, n plus 1, n plus 1 to the power cube over 3 n plus 1. Okay? So just copy it right now. Okay? Then denominator is a of n, right? So this guy. But it's be the reciprocal. So I gotta flip over. Right? So 3n negative 1 to the power n, the n cube. Okay? You guys good? So now I know it's really messy here, but you have to simplify. Otherwise, it's harder to make the limit because finally I have to take the limit. Okay, so let's simplify first. Yeah. But did you understand that if I take the absolute value, this guy, what do you see? What's that guy? Negative 1, take the absolute value. It's 1, right? So this one, actually it's not gonna, I don't care because it's just 1. This one too, right? Negative 1, take the absolute value. Again, it's just 1. Right? This goes 1, no? Just 1. This goes 1. Because you take the absolute value. So I really don't care here, this part. So let me rewrite. Okay. So I want to make sure this is n plus 1 cube that times by 3 to the power n. That's the numerator happening. Huh? Then let me write this guy first. Denominator n cube, right? Then this guy 3n plus 1. Okay. Because I just want to rewrite to make sure top and the bottom you can see clearly what's really happening. Okay. Is it okay so far? Okay. So look at this guy. Okay. Don't worry about that one. Look at that one. What's that? Can you cross out? If you simplify, what do you see here?
What?
3 to the power n over the 3 to the power n plus 1. No? What's that? What's this guy? Okay. This is just algebra. Make sure you understand it. This part. This part. What's the 3 to the power n over the 3 to the power n plus 1 means? This guy.
N minus plus.
Did you see that one? Did you understand this one? Right? Plus 1 meaning extra 1, right? Extra 3, right? That's the plus 1 mean, right? Right? If you have extra 1 more 3, that's a plus 1. Oh, I can see this guy cancel out. So it's just a 3. This meaning it's just 1 over 3 though. Does that make sense, guys?
Yes.
Okay, so make sure this guy, oh, it's just 1 over 3 happening. Okay. Yeah, what's happened? Okay, so now as I am going to take the limit, right? N goes infinity, this part. What's happening to my limit here? Here is n cubed, and then also denominator n cubed. Oh, same degree. What I say if it is same degree? It's a coefficient, 1 over 1. Oh, it's a 1 over 1 because coefficient is 1 over 1. Then this part is 1 over 3. Does that make sense? Then what's the answer? It's a 1 over 3. That's the limit.
Which is less than 1.
Yeah, which is less than 1. Oh, if it is less than 1, what do I say? Oh, it's a absolutely convergent. Absolutely convergent means it's just convergent. Oh, answer is convergent. Does that make sense? That's it. So answer is, okay, by, this is ratio test. By the ratio test, say, summation n equal 1 to infinity of the that one, negative 1 to the power n, n cube over 3 to the power n is absolutely convergent. Okay. Convergent. Which means more it's convergent, same. Which means same as just convergent. Okay. What do you think?
It makes sense.
That may make sense? Okay.
Yeah.
I want to do one more example. This guy, because I'm not sure you guys have ever seen that notations. this is I really wanna practice today, and then I will stop. Then we can do the one more test on Thursday. Okay. Have you ever seen the notations? This guy. Do you know this guy? This called factorial. Have you ever heard it? It's called factorial.
No.
No? Do you know this means? This means like, for example, this guy. Let's this symbol. This. Sorry, I'm gonna write. Nope. Okay. Have you ever seen that something like this? Right. This guy, 5 factorial. Have you ever seen that? 5 factorial meaning 1 times 2 times 3 times 4 times 5 means. This means just times by first to the until that number. That's a 5 factorial. 1 times 2 times 3
Oh,
times
I
4
remember
times.
that.
That's it. So if I have a 6 factorial meaning 1 times 2 times 3 times 4 times 5 times 6 means. Okay. So n factorial means 1 times 2 times 3 times 4 times 5 times 6 times forever until n number. That's the n factorial means. Okay. Just to make sure notation, you have to understand it. This guy. Right? Then when you see questions, factorial questions, you don't have a choice. You have to use ratio test. If you see that symbol, make sure you always have to use ratio test. You really don't have a choice. Okay. So ratio test meaning pretty much it's a factorial. Okay. So we're gonna do that. So a of n, these original questions. Okay. N to the power n, n factorial. Okay. So I need a of n plus 1. Okay. That means everything n plus 1 have to be happen. Okay. Instead of n, I have n plus 1. Then instead of n plus 1 power over n plus 1 to the factorial. So far okay? Everybody get that? Yes, now what you have to do? Let's take the fractions. A of n plus 1 over the a of n, put the absolute value, right? A of n plus 1 over the a of n, put the absolute value. Okay? So let me write for you this guy. N plus 1 to the n plus 1 power over n plus 1 to the factorial. That's a numerator happening. The denominator is that guy, but I know it's beta fractions reciprocal have to be happen. Okay? N factorial n. Okay? That guy. Did you copy? Yeah, I don't want to get confused here because this looks like lots of n's. Okay. So first you gotta make sure you have to simplify it because otherwise you cannot take the limit. Okay, finally I have to take the limit. Okay. Did you guys copy? You guys good? Okay, I don't want to get lost here. So listen carefully. Okay. Right now, n it's become the going to be infinity. So everything is positive number. This one, n equal 1, 2, 3, 4, 5. It's just everything positive. I don't care absolute value right now because everything positive right now. Right? So think about that way though. N plus 1 to the power n plus 1 right now. Okay? Then n to the power n. N factorial over n plus 1 factorial. I just rewrite this part so I can see clearly what can I cross out each other. Okay? So n plus 1 to the n plus 1 power, the n factorial. So numerator nothing change. The denominator I just switch it. N to the nth power, the n plus 1 to the factorial. Okay. Okay. So this part, everybody copy that? Everybody okay so far? Yeah. Don't look at here. Just look at here. How can I simplify this guy? This guy I cannot simplify. Don't cross out the n over n or something. No, don't cross out. Just pay attention to that part. Just look at that part. Okay. Right now. Yeah. So what's this means?
Over n?
Oh, everybody okay that? 1 over n. Did you understand that this one 1 over n? You guys okay here, right? N factorial means just 1 to the up to the n, right? So what's the n plus 1 factorial means, right? It's 1 times 2 times 3 times 4 times 5 times 6 times n times next number n plus 1, no? Right? You gotta pass the n because you have to go to the next number n plus 1. Right? Because the n plus 1 factorial. Does that make sense? So they are saying this divided by that. Right? That's the this part. That means, oh, bunch of the things I cross out. This is just left over. So this guy don't touch it. N plus 1. N plus 1 power, nothing I can do. N power, nothing I can do. But this part, I can see 1, n plus 1. Because I know I can cross out the top and the bottom, bunch of the stuff. So it's only n plus 1, it's be the leftover. Do you have any questions so far? Did you understand this part? How are we gonna crossing out this part? Top and the bottom. So you end up with that one. No? Yes. Now, okay. Everybody okay? So far good? Alright. Then last things. Yeah. Sorry, can you repeat it one more time? Okay, here you go. Okay. So look at this guy. This guy. N factorial, right? Until n. N plus 1 factorial means 1 times 2 times 3 times 5 times 5. It's n, but I have to go to the one more because one number bigger. N plus 1. Okay? So you are dividing top and the bottom. Right? N factorial over n plus 1 factorial. See that 1 cancel, 2 cancel, 3 cancel, 4 cancel, 5 cancel, even n cancel. So this is only the leftover. That's why this guy become 1 over n plus 1. Are you get it? Did you guys get it? You get? Okay, yes, good. Yes, finally, this is the last things. Finally, it's almost we are done. Okay. How do you simplify that guy? That one looks more still complicated, right? Because so many n happening. But here is I want to take a look. Okay. So look at this guy. This part. Pay attention to that part. Okay. N plus 1 to the power n. There the plus 1 happening. Which means another n plus 1 happening, right? If we have a plus 1 means there's another n plus 1 happening over n, the n plus 1. Did you see that? Because of this extra 1, I separate it, right? It's extra 1 here. The denominator nothing change, right? N to the nth power and n plus 1. But nice thing about here, did you see? Oh, n plus 1 over n plus 1. Oh, I can cross out right here. Okay. Yes, so now it's almost there, though. It's almost there. N plus 1 to the power n over the n to the power n happening. Over the power n happening. But here is, you have to refresh. How do you take that limit? I need to take that limit.
Coefficient?
Okay, this guy. You guys remember? Same power n. So I can make the exactly the one big one fractions. And I can, take the one big n outside. So n plus 1 over the n because same exponents, I can do it. Then, sorry, I gotta do the last things. This is, I can separate it, right? N over n, 1. Then 1 over n. Right? N over n is 1, 1 over n to the power n. Now, hopefully you guys remember the that limit. What happens as n goes infinity? Are you guys remember this infinity? 1 over infinity over the infinity happening that one. Have you ever remember that one? This is
Doesn't that become...
Yeah.
I'm sorry.
Yeah, go ahead, go ahead.
Doesn't that become E?
Yes,
like
yes.
Yeah, right? Oh.
This is a definition for the E. Do you remember the that limit? You have to remember that it's a calculus 1. This is a definition for the E. 1 over n, 1 plus 1 over n over the power n is a E. Okay, if you don't remember, make sure just refresh. This is actually definition for the E means. Oh, so we end up the E. E is bigger than what? Bigger than 1, right? Clearly. E is 2.1417 something, right? So what I say? If limit is bigger than 1, what's the answer say?
Divergent.
Divergent. Oh, limit is bigger than 1. Finally, my answer is, okay, by root test, by the ratio test. This guy, n equal 1 to infinity, n to the power n factorial, is divergent. So that's it.
Professor, I did have one question.
Sure.
So, you know in the part where you canceled out the n plus 1 on the numerator and denominator?
N plus 1, right here? Yeah.
Yeah, okay. Where exactly did you get that n plus 1?
This plus 1. Did you see? There's a plus 1 happening.
Right.
So this means n plus 1 to the power n, and then 1 more n plus 1 means. Right? N and then plus 1, right? N plus 1. This is n plus 1.
Oh, okay. So you just like kind of separated
Yeah,
it in a way?
separated it. Because this plus 1 means 1 more n plus 1 is happening. That's this means.
Oh, okay.
Okay. Yeah.
Thank you.
You're welcome. Okay. So once you get the divergent, we are done. Don't do anything. Just divergent. There's no conditionally convergent or anything happening. No. It's just absolutely convergent or divergent. The answer is divergent. So we are done. Divergent. You guys okay here? What do you think? Did you understand how to simplify that part?
Yeah, it's pretty easy.
Pretty easy? Okay, that's great.
Not too bad.
Not too bad? Alright. Yes, I think we did enough today. Alright. So,
Yes.
I will continue on Thursday root test. Root test is actually it's easier. Ratio test, I did a couple more examples because some of the technique I didn't want to make sure you understand how to simplify but. Okay. So, ratio test, I'm going to do a couple more examples and then we're going to do the root test. Then we will go to the power series. That's the hard one. That is nothing to do with test. We are done for the test, completely done. So that's the last things I have to the chapter 11. It's a power series. That's the hard one. So just make sure Thursday you should show up. Okay. If you have any questions, let me know. Are you going to the? When are we going to do the test 4? Are we going to do the study guide? Oh, it's exam 4. I put the module. Okay, so let's talk about the exam 4. Okay. So let me show you the exam 4. Okay. Let me make sure. So I will show you the. Just too many kind of computer is opening up. Let me see. Opening. Okay. Yes. Okay. Let me show you. Yeah. Okay. So you guys have the modulo, right? So make sure always check the modulo, so you can see weekly. So if you go down, we are doing right now this part, right? So we are working on the right now here, chapter 11 again. Then if you go down next week, we still have to cover the chapter 11. Then you go here. It's B. See that? Sorry, exam chapter 11, it's B. On Thursday, 14th, again 7 to 9. Just like last exam you guys took it. Chapter 11 exam. And then practice exam, it's be web assign. I already make the practice exam, chapter 11. So should be, you can find the practice exam chapter 11 in the web assign too as well. You guys good?
Are we still gonna have like those numbers of attempt for the exam?
Yeah. You mean say again? What did you say?
Oh no, I had asked if we were gonna still have like those 3 attempts.
Yeah. Just like last exam. Yeah, just like last exam. It will be the same attempt. Okay. Yes, you can do. So that's the week. That's the week. Make sure it's before the 14th. But next week, it will be your final exam. Okay. So week after it will be the final exam. You guys okay?
Yeah.
Alright, so it's just that's the week, and the next week you guys have a tense schedule. Again, I have a practice final exam ready, and then you guys take the final exam on next Thursday, not the 14th, probably 22nd or something. That's your final exam. Okay. You guys good?
Yes. Professor?
Yes, what's that?
Do you have office hours tomorrow?
Tomorrow, I can make the office hours, but sorry, I have a meeting 2:30. So I can do office hours like the night time, because I have another class after 3 to 4. After 5, I can make the office hours, or morning, I can make the office hours. So it's up to you guys. If you want office hours after 5, I can do the office hours after 5 o'clock. Or I can make the office hours. I think I have a meeting 12:30, after 12:30 to 1. That's another office hours I can make. But I have a 2:30 meeting, so I cannot do the 2:30 office hours. So which one you guys want?
I could do whichever, the noon or the after 5 one.
I can make the after 5 o'clock office hours, or I can do after 12:30 office hours, 12:30 to 1:30 or something. Yeah, I have a meeting up to the 12:30 tomorrow. Yeah, so after 12:30 to the 1 or something. So it's up to you guys. Which time is better for you guys?
Like
5?
Yeah.
Yeah, I could do the 5 o'clock one.
5 o'clock is good? So that case I can make the 5 o'clock office hours. That's fine for me. Then I will set up the 5 o'clock Zoom. So I'm gonna post the announcement. So if you need any help, like show up the 5 o'clock. You guys okay?
Okay.
Alright.
Okay.
Alright.
Thanks, Professor.
You are welcome. Then maybe see you guys.
Have a good one.
Yes,
Professor.
you too. Good night. See you tomorrow.
Good night.
Bye.